Hello, everyone, and welcome back to our series on knowledge tracing. In our previous videos, we covered the fundamentals of Bayesian knowledge tracing, or BKT. Today, we're taking it to the next level. We'll explore three powerful extensions that make BKT even more accurate and applicable to real-world learning scenarios. By the end of this video, you'll understand multi-skill BKT, contextual guess, and slip BKT, and individualized BKT. Let's get started. Before we jump into the solutions, let's quickly recap why we need them. The original BKT model is a fantastic starting point, but it has three main limitations. First, it's designed to track only one skill at a time. But think about it. Solving a complex math problem usually requires multiple skills, right? Second, it assumes a student's chance to guess correctly or slip up is the same for every question, which isn't true. And finally, it treats every student the same, ignoring the fact that some students are more prone to carelessness than others. These are the problems our three extensions aim to solve. To overcome these limitations, researchers have developed three key extensions. Today, we'll focus on these three: multi-skill BKT, or MS-BKT, which handles multiple skills at once; contextual guess and slip BKT, or CGS-BKT, which smartly adjusts the guess and slip probabilities based on the question itself; and finally, individualized BKT, or IBKT, which tailors the model to each student's unique learning profile. Let's break them down one by one. First up is multi-skill BKT, or MS-BKT. Let's use a simple analogy. Imagine a teacher tracking a student's progress. A basic BKT teacher has one sheet for one subject. An MS-BKT teacher has multiple sheets, one for each subject the student is learning, and importantly, the teacher understands how these subjects are connected. For example, mastering linear equations helps with learning quadratic equations. The core idea is that instead of a single probability value, we now have a vector of probabilities, one for each skill. Let's make this concrete with our friend Xiaoming. Suppose he's learning two math skills: linear equations and quadratic equations. Initially, we estimate he has a 30% chance of knowing linear equations and a 20% chance for quadratic equations. Now, he encounters a problem that requires both skills and gets it right. We first perform the observation update for linear equations, raising his probability to about 38%. Then, we apply the learning update, increasing it further to roughly 50%. Crucially, we do the exact same calculation for quadratic equations, because the question tested that skill too. So, with one single action, we've updated his progress in two different areas. That's the power of MS-BKT. Next, let's talk about CGS-BKT, the contextual guess and slip model. Remember the second limitation of basic BKT? It assumed a fixed chance of guessing or slipping up. CGS-BKT fixes this by making G and S dynamic. Think of it as a smart teacher who knows that a student is more likely to guess correctly on a simple multiple-choice question than on a hard essay question. So, instead of using a single value for G, we calculate it based on the question's features, like its type or difficulty level. The same goes for the slip probability S. Let's see how this works with Xiaoming again. Suppose he gets a question wrong. In basic BKT, we just plug in a fixed G value. But with CGS BKT, we look at the question. If it's an easy multiple-choice question, we set a higher guess probability, say 25%. Plugging this into our formula, his knowledge state drops to about 7.9%. But what if the question was a difficult fill-in-the-blank? It's much harder to guess, so we set G to a low value, like 5%. Now, the same wrong answer results in his knowledge state dropping even further to 6.3%. The system correctly infers that getting a hard question wrong is a stronger sign of not knowing the material. This makes the model much more nuanced and accurate. Our final extension is IBKT, or Individualized BKT. This one tackles the one-size-fits-all problem. Basic BKT uses the same parameters for every student, but we all know students are different. IBKT solves this by giving each student their own personalized set of parameters. It's like a teacher who learns about their students over time. They might realize that Xiao Ming is a smart student, but very careless, so they assign him a higher slip probability. Or they might know that a new student, Xiao Gang, is starting from scratch, so they set a very low initial knowledge level for him. These parameters are learned and updated as the student interacts with the system. Let's bring back Xiao Ming, our careless student. In a basic BKT model, if he gets a question wrong, his knowledge level drops significantly to just 7.9%. But with IBKT, the system has learned that he's prone to slipping up. So we use his personalized slip probability, which is higher, say 25%. When we perform the calculation with this higher S value, his knowledge state only drops to about 10.6%. The system is effectively saying, this is probably just Xiao Ming being careless again, rather than assuming he suddenly forgot everything. This personalization leads to a much more accurate and fair assessment of his true knowledge state. So, let's quickly summarize what we've learned. MSBKT allows us to track multiple skills at once, which is essential for complex learning tasks. CGS-BKT makes our model smarter by adjusting guess and slip probabilities based on the type of question being asked. And IBKT personalizes the entire model for each student, recognizing their unique strengths and weaknesses. Together, these extensions transform BKT from a simple theoretical model into a powerful tool for real-world adaptive learning systems. In conclusion, these three extensions, MSBKT, CGS-BKT, and IBKT, are crucial advancements that make knowledge tracing far more powerful and realistic. They address the core limitations of the original BKT model and are fundamental building blocks in modern educational technology. As we look to the future, we'll see these concepts combined with deep learning and other AI techniques to create even more sophisticated and effective learning experiences. Thank you for watching. Now, I'd be happy to answer any questions you might have.